Hi, this is Chris Schomburg, and today we're going to talk about a lab number 6, and it's called How a Diode Works. So we're going to learn about diodes, and diodes are actually probably the most important thing you'll learn in the subject of AC-DC or DC-AC, and why that is because really what we do is almost all of our energy is generated in an alternating current, meaning alternating directions, one direction and then the other direction. And so most of our energy is generated in alternating current, and it either has to be synced up to the grid or it has to be converted to DC signal and then converted to an AC signal. Now also, almost all of our appliances then take this AC signal or alternating current going in opposite directions and then create a DC signal to be able to power it up. So it's funny, if we think about it, almost everything, if we think about the first generated AC signal was a hydroelectric station, maybe in Ames in Colorado, in Telluride, or it could have been also another one that's very close to the same time frame was Niagara Falls, which was a hydroelectric generation. So we have hydroelectric, which is AC. Very soon after that came quite a few other generation, which is wind generation, which also is AC. If we think about tidal energy, that's AC. If we think about nuclear, that's AC. If we think about even geothermal, that's going to be somewhat of an AC signal. And then really, so that's 5 different types of AC signals that we can think about. Typically, if we think about DC, the only DC signal that's always DC is a solar panel. Solar panels are DC and always DC. So most of our signals that we think about either turn a turbine, which is either a Francis or a Pelton turbine, and they actually then create an alternating current. Okay, so either that's through water or through steam or through gas or through air, and that's like a wind turbine. So most of them are alternating current. So typically we have an alternating current that we want to convert to a DC current, and to do that you can use a diode. Now it's much more complex than that when you actually look at an AC to DC converter, but typically what we can see is that even in an AC and DC converter, we're always going to have a standard diode. And so you can think of a diode really as a one-way traffic of electrons. So like a one-way street, we only go in one direction. That's what a diode allows us to do. It only allows the current to go in one direction. Now you can also think of it as a one-way valve. Our heart, the aorta in our heart actually has valves that only allow blood to flow in one direction too. So it's pretty amazing that we can actually use this device to allow electrons to flow in only one direction. Now the amazing thing about electrons is they move at 99% of the speed of light. So they actually somehow see the circuit before we even put it in. So it's really kind of amazing how quickly they work. So that's kind of an amazing thing too. We're going to introduce you to 2 new different devices. This right here is a multimeter, and then the other new device obviously is the diode, and that is actually in the all components. We're going to have to click on all components instead of basic and get that from our Tinkercad. The other device this is a third device, I didn't mention it, but a third device that I want you to learn about is we've kind of graduated away from the 9-volt power supply from the 9-volt battery, and we can actually use a power supply now. It's a little bit more complicated, but it allows us to put a range of voltage instead of just a single voltage. Okay, so let's go ahead and get started here, and let's look at what we could do. So the basic circuit is the same as we normally have. We would normally rotate our 9-volt battery. We would put it vertically right here. I'm going to move everything down. Okay, we're going to go right here. I'm going to do it from the left side this time, so this is positive. We're going to go red, and then we're going to go negative. Again, I'm just putting it on one side of the rail because it's a little easier to use. Okay, now the funny thing is that now I can actually move this around, and I can move this so it's now centered, and we have it totally centered. Okay, so I can actually move this around however I want it. So now what's cool then is that the diode actually, what it has is it has an anode side, which is this side, and the cathode side, which is the bottom side. Now in that case, if we think about it, the anode side is always the positive side. So we're going to go ahead, these go like that, so we're going to go right here, and we're going to put this right here, we're going to put it in, I'm going to put it in the center, so I'm going to put it in C1 as the anode, and C5 as the cathode. So we're going to go ahead, we're going to put in the power to this. So we're going to go right here from the red rail. We're going to go into power, right, like that is red. And then our black rail, we're going to go down here, and we could put it directly in. But remember, we always want a resistor in everything that we do. So I'm going to put the resistor right there, and then I'm going to put this in here. If it didn't have the resistor, it would have a really high current. That wouldn't be a good thing. We would not want to actually burn out our diode. And so we can just do this. Now, I'm going to tell you, the diode is basically the exact same thing as an LED. The only difference between an LED and a diode is that this is a lot cheaper. Okay, it doesn't emit light, and so you want to save money, you want to use a diode in this case. They are both diodes. This is a light emitting diode, and this is just a diode by itself. So you can assume that this one would be a lot cheaper to actually make and use, and this one is a lot more expensive, so you don't want to burn that out as much. So, okay, so we now have the negative going here. The electron flow would be going from the negative right here to through the resistor, through the diode, and then through the positive. Okay, now if we go ahead and we hit this, we're not going to see anything, right? So typically we would have our LED, so typically we would have something like this, and we would have, we would actually want to rotate it a little bit more. This would be the negative side, right? And then this would be the positive side, and I'm going to bypass the diode and put in the LED. Okay, so typically we would see something like that, and I am bypassing the diode. Let's just a second here. I'm going to actually have to bypass it. So I'm going to put in a jumper here. This is what I call a jumper. Okay, so I'm going to actually just pull it out for now. Okay, now we see the LED is lighting, the light emitting diode is lighting, there we go. Now if we go ahead and reverse this, right, that does not work. Okay, so the light does not light up. It's because it only is a one-way valve, it only allows the current to go one direction. Now, we're going to delete, okay, we're going to delete our LED, we're going to delete this, we're going to put in the diode. Okay, we're not going to see anything, right? So how do we see something? So instead of using an LED, we're going to use a multimeter. So here now we're going to put the positive side right here. Okay, we're going to put that as red. I'm going to just move this up so it's easier to see. And then I'm going to go to the negative side, and I'm going to click, and then I'm going to click over here onto this rail, that, and hit a black. Okay. Now if we start this, we actually see that we have 9 volts. Okay, so we're seeing a voltage here. Between here and here is 9 volts. That's good. Okay, now let's see if there's a current. Okay, we do get a 6 amp current. Okay, now why would we be seeing a 6 amp current? Well, that's kind of interesting because that's not real great. Because what we want for current is we want actually in series. So that's not real good. It's not making a lot of sense. We're not going to do that. So what we're going to do then is we want to put this in series. So to do that, what we're going to do is we're going to actually have to pull one of these items out. Now the easiest is to probably put the diode there. and probably put this let's see, go ahead. I need one space really, so I'm going to go down one, and then I'm going to move all of these negatives down one. So we're going to go right here to here. We're going to put that as black. There we go. Then we're going to go right here, and from this guy I'm going to go here into my meter, and that's going to be black. Okay. And technically it's not, well, it's technically not truly black. It's going to be, there's going to be a voltage drop here. But then we're going to go ahead and we're going to go from here. This is going to be series. So I'm going to go from here to here. And again, I'm going to call this one black, but let's actually call it orange. Okay, and let's actually call this one brown. Okay, so we're going from here to here to here. Now we are in series. We can measure that, and we measure an amperage. Now this is 8.4 milliamps. Okay, so if we have 9 volts, right? We divide 9 volts by the resistance, and so assuming like this is 100 kiloohms. Okay, so let's get out a calculator. Okay. All right, let's do it the simple. Well, we have a calculator, so let's just do it the easy way or the hard way first. Let's go 9 volts divided by 1,000. Okay, we should get 0.009 amps. Now, this is in milliamps, so we know that's going to be times 1,000. So we should get about 9 milliamps. We do. We get 8.4. Now, why is this 8.4 instead of 9? You might be thinking, okay, something has to be taking up that extra voltage, okay, or the extra voltage or amperage. So what could it be? Now let's think. The diode right here is going to actually take some sort of voltage out, and so that actually is probably why we have 8.4 milliamps versus 9 milliamps. Okay, so that's the key point here. There is some voltage drop and current loss, some power loss through this diode, and there's some power loss through the resistor. Okay, it's minimal through the diode and it's minimal through the resistor. Now let's take it a step further. Okay, so I'm going to actually copy this. Oh, I have to stop the simulation first, but let's go ahead and copy that, and let's actually measure how much voltage wise we're dropping between each element. So right here we're going to go, okay, let's go ahead. I'm going to put this right here. Well, okay, let's put one right here and the other one up here. Okay, so one of them is going to be the diode, the other one is going to be so we're going to put that one as the diode. I really don't like how this works because it's just funny how it has the inputs at different points. Okay, so we can actually put this as red, and we can put this one as black. Okay, so now we always measure voltage in parallel. Okay, so this is amperage, we want it to be voltage. We measure the voltage in parallel. Okay, I'm going to put this next one over here. We're going to put this one as red, and then we're going to put this one as black. There we go. Come on. Connect. Okay. So that one as black. Okay. So there we go. Now, we want this one as voltage as well. Okay. So now we're just going to measure the voltage drop for each one and the current. So right here, we have, this is 8.4 volts. Okay. So we know it's a total of 9 volts. So this is 8.4. And then this is about 0.6 0.6 volts. Okay, and you can see we add that up, that actually adds up to 9. But we can actually, I know some of us probably are not as used to seeing that right off the bat, so we're going to actually add it up. So we go 9 volts. Okay, so we have 9 volts here, and then we actually subtract 9 minus 5 point, oh sorry, okay, 9 minus, oh, being silly, not erasing, okay, 9 minus 0.59, okay, we're going to get 8.41 minus 8.4, we're going to get 0.01. So assumingly the 9 volts here is being supplied and then it's being consumed, we're consuming all that power. So that's actually very accurate. It's actually fairly darn accurate to what I think we should see in reality. Now, obviously that's only true if this is truly 9 volts. You're going to have batteries that are going to be between 9 volts and then could reduce down to, you know, 7 or 6 volts. So it depends if you have a good new battery, if you're actually going to see that voltage there. And then the elements a diode should be about 0.6 volts. Okay, so about 0.6 volts. So about half a volt is a little bit over a half a volt is what a diode will drop the voltage. It's how much it consumes voltage wise. So then the resistor will depend on what type of resistor you're using and the voltage that you have. So that's, I mean, that's kind of, it's going to be dependent. But right here, so that's how much that is. That's the power consumption in this case. So it's going to go. Typically, that's what you're going to see. So yeah. So now we've actually graduated from using the 9-volt battery. We will still use those with the kits because that's what we have supplied to us. But in labs, what we typically do is we're going to actually go ahead and we're going to delete this 9-volt battery. And we're going to introduce a power supply. Okay, so the power supply, in this case, we're going to put positive to positive. Okay, so here we go. We're going to hit positive to positive. And we're going to go negative to negative. Okay, and that is going to be, okay, so this is black, so that's negative, and this one right here, wait, it's really not working. Okay, this one is red. So there we go. So now we have positive, positive, negative to negative. Okay. Now the nice thing about this is we can actually say how much voltage we want. So typically your USB cables for your phones and those kinds of things are 5 volts. You can actually say how much current you want. So let's go ahead and let's put 9 volts. Okay, let's start. Okay, so if we have 9 volts here, then we can actually see something very similar here to what we had with the battery, right? So we're seeing the same type of current here. We're seeing a similar current here. We're seeing a similar voltage, and so we're seeing that same similar thing with the 9-volt battery. The nice thing about a power supply is you could actually make it mirror, instead of a 9-volt battery, we could make it mirror like a 12-volt battery out of a car. Okay, or let's say 16 volts to 24 volts out of solar. Okay, so this could be like a solar panel supply at 16 volts or 24 volts. That could be between a 25 watt to a 100 watt solar panel. So that could be a solar panel that we're supplying here instead of a DC battery. So that could be something that we could be looking at too. What other typical loads could we do? You know, we could reduce it down to a 5-volt load, and that would be something that would be off of a USB. Okay, like a USB for your computer or for phones or things like that. So that's typically actually where we're going in the future. I think most electronics in the house are going to be reduced down to a 5-volt supply. Why do I think that? It's just much more efficient. It uses a lot less power. There's a lot less drain. I think that's typically where we're going to go to. I don't know for sure, but I think most powered on devices are using a 5-volt supply instead of the 9-volt supply. Okay. So yeah, so we graduated. We've actually used right here. We've graduated from the 9-volt battery to a power supply, to something that we can actually adjust and attenuate. Okay. So that's what I have for the first lesson of how a diode works. I have a little bit more that I'd like to talk about with diodes, especially if you go ahead and want to see how to convert AC to DC power. So we'll look at that in a second.